The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, and so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO, Ken Hahn, on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed, and we knew we were getting to the local community, and people were asking questions. So those were the best. I think I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well, and we got to a lot of people we wouldn't have normally gotten.
Hello everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from HVERI, the Hawaiian Volcano Education and Resilience Institute. This is our Hawaiian Volcano summary update for July 11th, 2024. And the volcano has been showing a little bit of interesting activity this past week, but we'll get into that first. How are you, Dane?
Oh, doing good, doing good. Good to have you back.
Thanks.
Out of the hot seat for a little while, or was in the hot seat for a little while. Good to be back to our normal presentation.
Yeah, for sure. Yeah, thank you guys for holding down the fort, you and Lou, while I was gone here, and yeah, I got to contribute a little bit and excitement on the volcano, which is cooperated by not erupting, I suppose. Well, she could have. Could
have been a little quieter too for that first week, but hey, I'm not complaining.
Right. So yeah, we'll get into the activity over this past week. We'll do our recap of the monitoring data as usual. And then we'll take a little break. We have a new fundraiser starting this month, so we'll get into that a little bit. And then we have a short video in the back half that is a revisit of this 2-week period in 2018 when there were some overflows from the lava channel. There was small explosions from Fissure 22. There was a loss of the Kīlauea school, impact on sea life. So we'll get into all of that a little bit later as well. So, yeah. Anything else before we get into all of that, Dane?
If anybody has any questions, go ahead and put them in the chat. We'll be doing 2 segments. So questions about current activity in the beginning, and then questions about maybe 2018 or a wider variety of questions at the end. So if you have a question, go ahead and get them in the chat.
Sounds good. Thanks, Dane, for leading that discussion out there. So I guess we will transition and start off with our Hawaiian volcano summary. So let me get our screen situated here. And okay, here we go. This is our Hawaiian volcano summary for July 11th, 2024. Kilauea has exhibited some cycles of earthquakes following the June 27th, July 1st Upper East Rift earthquake swarm. And that has triggered a magnitude 4.1 earthquake on the south flank, just south of the Nepal crater area, all through there. The volcano was overall inflating, as you can see by the earthquake pattern over not only the last month, but over the last week here, where following that earthquake swarm, we had a burst of activity in the Upper East Rift following this 4.1, which in the more recent days has shifted to the South Caldera area over here. Both these areas have been activated with earthquakes since that swarm, showing 2 different reservoir areas that are pressurized most immediately under Kilauea today here. So the volcano continues to pressurize, and according to the USGS HVO, any substantial increases in seismicity and or deformation could result in a new eruptive episode, but there are no signs of an imminent eruption at this time. So that's the earthquake map there. And I can also share the earthquake rates here. So here is our earthquake swarm that occurred a couple weeks ago. And this is that big event that occurred, that 4.1, with the following aftershock sequence that occurred there. And now we have earthquakes picking back up in the South Caldera today. Looking at the ground tilt signal, this is the Sand Hill station. We are still showing significant inflation, especially in that South Caldera connector, as well as in that main caldera, Halemau area more recently over the past week here. Note the scale on this graph here. These are big changes. Also, we have a new image released from satellite data by the USGS. This is tracking since the end of that eruption, a few days afterwards, June 6th to July 8th, and showing that beyond the trace of the dike that caused the eruption on June 3rd, we've had a big pulse of inflation here in the South Caldera / Southwest Rift connector area. So just showing how quickly the volcano has refilled and repressurized since that eruption in only 1 month. That's the story on Kilauea. Mauna Loa is still refilling following its 2022 eruption. Overall, that's fairly quiet, but over this past month, you can see this tilt plot. Within the last week, we may have had a slight bump in this inflation rate here. Nothing to be alarmed about. It's still fairly small scale, And if we look at the main GPS station across Caldera, north and south, we can see that the Caldera continues to extend as this inflation pattern has been present for several years now. So no cause for alarm there, and Mauna Loa continues to behave as expected. And that's our Hawaiian volcano summary for this week. Mahalo. So we'll go from that into our Kilauea observations. And I can start off by showing the now back online live feed from USGS here through YouTube, showing some passive degassing from all that cooling magma and lava that's underneath this crusted over lava lake. And we saw this whole area flooded with lava as recently as September last year. So otherwise fairly quiet, lots of mineral buildup coming across the crusted crater floor here, but not much else happening now apart from having a live feedback, which is pretty cool. So those are our limited observations this week. We'll get into the hazards, which continue to be primarily the gases you see emitted here. So for that, we'll turn to the VOG measurement prediction project group from University of Hawaii at Manoa, which produces this VOG forecast map, with our sources being Kilauea here, both the summit and the southwest rift site that's about 2 miles away, and Mauna Loa, although no gas is coming from there at present. Still, with the current weather patterns, this is the predicted concentration of gases here. Nothing very intense, but could still affect sensitive individuals in nearby areas. The closest area to the emission sources that people are likely to go is a national park, and there everything is still in the green. So all clear there as far as our hazards. So having stepped through those two, we'll go into our earthquakes, which is where most of the action is happening these days. And we'll first turn to this USGS page that is plotting earthquakes, coloring them by depth. So here, all the blues, here, put up the scale, the key for you guys. All the blues are deep earthquakes. So you're looking at light blue, more than 12 miles, deep blue, more than 25 miles or so. The reds being the shallower ones, and you might see some oranges in between. Oranges and yellows. We don't see too many of the green in the green range here in Kilauea. But there is a range across Hawaii Island. You see some background events of various depths all across, including some green ones here and here. We see the blue patch of deep Pahala earthquakes still ongoing there. We can see a smattering of shallower earthquakes on Mauna Loa, especially on the southeast flank right here. There's quite a lot of intermediate and shallower events there, which is likely related to adjustment to Kilauea, which is neighboring on that side. And then otherwise, most of the events fall into this little cluster at Kilauea right here, with a few lesser crowded dots here towards the lower east rift, but nothing alarming there, just regular background events there. Zooming into the Kilauea area, let's get into there and get some more resolution on these events here. So yeah, that looks pretty good right there. This right here is our magnitude 4.1 that occurred 4.2 miles down. This was on Saturday night at about 8:45 p.m. or so. There was an immediate aftershock of a 3.3 right then, and then a few other smaller ones that followed closer to magnitude 2 there. So that was the bigger event. And then following that is when we saw the increase of events on this upper east rift connector right through here, at the same area that was the focus of that swarm that occurred at the end of June and beginning in July. So it really began there. Began here with earthquakes also occurring in the South Caldera. And as time went on, we got fewer earthquakes here and more earthquakes here, especially in the last couple of days here. But overall, what you can see is there's a few events down here towards the eruption site in the Southwest Rift. So perhaps there's a pathway still open there as well. It seems likely, in fact, just activated without as many earthquakes. And beyond that, we really don't know, because that area also wasn't treated without earthquakes in the most recent eruption, and hard to tell what's happening down there. So those are the events here colored by depth. If we can note that that 4.1 event did trigger a USGS information statement in which they noted where the earthquake occurred, 9 miles south of Fern Forest, the aftershocks that occurred, 202633, and no impact on the volcanoes or anything like that. Right? They don't really go into much more than that, but we will get into a little bit more here in a little bit. But first, continue to recap. We'll see those same events. Here they are plotted by time. So red is now the most recent hour, orange the most recent day, yellow the most recent week. Right. So, and with that, you can zoom in here. And actually today, it looks like the most recent events within the last hour now have returned back to this upper east rift zone here. But you see most of the oranges are actually over in this cluster over here. Not exclusively there, right? There's still some over here. But you can see that shift beginning to occur there. And that's just what's happening today. They will likely switch back, flip-flop back and forth. What we've seen is a long-term pattern of pressure building on Kilauea in different areas, different centers in the volcano, and flip-flopping around between the Southwest Rift, the Halemaumau area, the Upper East Rift Connector is now part of it, and that whole triangle south of there, the whole Kauai Fault Zone as well. So all of that is showing the breadth of how much the volcano is pressurized and adjusting and finding ways to accommodate all that magma that's coming in underground. So it's pretty interesting to see all these adjustments. The earthquake rates are actually quite high to the point where I'll start saying that we should also be prepared for earthquake hazards beyond just the gas hazards, right? The gas hazards are the most continuous present for everybody, but they only affect people who are nearby. Whereas any earthquake that occurs will be potentially felt and having effects island-wide, right? So that 4.1 that just occurred was a subject of Volcano Watch. So let me put that on the screen here right now for you guys. Volcano Watch, which starts off with this image of the felt reports that were submitted. 719 responses plotted there within, I'm not sure how many hours here, but within, it looks like 4 or 5 hours of that earthquake actually happening. So fell all the way to Kohala, you see, all the way around, almost fully all the way around the island here. And so we'll get into this a little bit further, but it does note that earthquakes in the south flank are fairly common. And the most recent big one was a 6.9 that occurred in May 2018. Prior to that, also, let me just say that that event obviously allowed magma to move down into the lower East Rift at that point in time. So this is not quite the same thing we have going on here, but it is part of the same overall process. Now magma is not even yet to the Middle East Rift Zone, so it has a ways to go to get there. But this is the process that we're seeing unfold now, is that progression of the restoration of magma to that Middle East Rift Zone. And yeah, and we'll see what happens from there. So 6.9 2018, 6.2 in 1989. That was during a Kupainaha eruption. I remember the pool eruption is divided into episodes. There was a high fountains pool, then there was a fissure east of there. It made a lava lake called Kupainaha that overflowed and erupted for about 5 years or so before it went back to pool for the long-lived, more gentle lava flows that made lava tubes all the way to the coast. So this event was part of that magma pushing into the Middle East Rift Zone as well in 1989. And then one prior to that was quite large as well, was a 7.7 in 1975. And that was the one that caused a small tsunami at Halape with 2 fatalities, and ultimately was what led to the pool eruption. Right? We know that the massive movement of the south flank in 75 opened the pathway for magma to work its way back through a series of small eruptions and deformation to ultimately erupt at Pu'o'o in 1983. So it took many years for that to happen, 8 years after that 7.7 event. But that's something that's fairly well discussed in the literature today, how important that actually was. So the natural question for us then is that even though our 4.1 was only a minor slip among that Tacoma, like what part does it play within a larger context? And so we'll look at some a couple other factors as we discuss this in our GPS going through here. So, but before we get to that, let's look at the monitoring signals. And to start our monitoring signals, I'll just review the highlights from today's USGS daily update. And they note that, well, I'll start off by saying that the daily updates have included more detailed information recently, and they are noting day to day how many earthquakes are being detected beneath the South Caldera, in this case, over the past 24 hours, 52, as well as beneath the Upper East Rift Zone. In this case, it was just 5. But at previous points during a week, they were reporting different proportions. For example, you might have 10 or 20 in the South Caldera, and you might have 50 or 100 in the Upper East Rift. So it's been quite variable there as well. They do note here, this is where I took that quote, that any substantial increases in seismicity or deformation could result in a new eruption, but there is no signs of anything imminent. There's quite a lot of details in here that I don't want to read word for word, but I'll just recap a little bit of the other stuff. They are still noting inflation of the volcano through tilt meters at Sand Hill, as well as Uikahuna at the summit. They're showing that on GPS as well. And they are seeing SO2 emission rate went down slightly, but it's still within that background range that we've described previously. That's really the highlight of the science there. There is some monitoring notices, such as the V1 camera, which we pointed out in our live feed, is been repaired back online. They had actually had to go out, identify the issue, go back to the lab, get a replacement part, go back out there, replace it, and after all that, they now have that repaired and back online, thankfully. We previously mentioned that the Uikahuna tilt meter had been recalibrated, and because it had been done physically, that requires several weeks for the signal to recover. And so you can't look at the exact measurement of microradians on there, but you can take the overall pattern as being an indication of what the volcano is actually doing. So if it's going up, it's likely inflating. If it's going down, it's likely deflating. By how much, maybe that is harder to believe on Uikahuna going by itself, right? But overall, they are still fairly confident it's showing inflation. The other tilt meter that we often use, the Sand Hill tilt meter, has also been releveled. However, it's been releveled digitally. So because it was not done manually physically, it's immediately okay again. And they've actually cleaned the data so that the plot that we see online is fairly accurate and indicating the actual changes happening on the ground there. So there's a lot of maintenance happening in the back end with the USGS there, and good to see things coming online with them. So that is our text update. And I'm going to scroll up here to show you guys our monitoring spread. So there we have the tilt for the last week, and the recalibration occurred just over a week ago. So if you're looking at this plot earlier in the week, you might have noticed a different character of the signal than you see here now. And when we turn to our monthly plot, we'll see that a little bit as well. But now it seems fairly stable. You see the ups and downs. We seem to be a little bit less sensitive to the deflation inflation events, it appears, on the signal so far. Or there was some extra sensitivity due to some other factor of calibration before as well. Earthquake counts over the last week. Here is that little bell curve pattern, with a big event shown as this red line offset. And so if you haven't watched us for a while and heard explanation of this particular graph, the blue bars are earthquakes per day, measured on this side, but the red line corresponds to this cumulative moment, which is a measure of energy, which is related to magnitude. So think of it as stacking magnitudes of earthquakes one on the other. And so here you see the biggest release of energy was through that 4.1 right there. And then you see all the high counts of events and all the days that includes where that's included and follow here. On our depth versus time plot, there is that event that was down at 7-8 kilometers down. Is that right? Did I say it wrong? Maybe it was a little shallower than that. And you can see the pattern of the orange and reds being the shallower events there within the magma pressure system. So a little bit of a gap right through there prior to today's resumption in the South Caldera. You can see these little bursts of earthquake events occurring both in the Upper East Rift and the South Caldera there. And there's a map we showed earlier. So keep going from there. I mean, one thing I wanted to point out here, and it's a little more detail, is maybe you have noticed this, that this line of Upper East Rift earthquakes and Upper East Rift itself is going to point directly to the epicenter of this big event on the south flank. And so you can imagine that as that pressure is built all through here, right? But it's maybe what's important to think about in this context is how far is the pressure wave actually reached. And so we're seeing earthquakes all the way up to the bend of the Upper East Rift and the Middle East Rift zone right here. And if you're pressurizing this point right in here, right, you can imagine it's going to want to affect an area that's out seaward of that. And it turns out that the way I see it, the way I imagine this, interpret this, is we've been seeing earthquakes occurring in this sector for quite a while as we see pressure from the summit more directly pushing south on this. So this event's been moving quite a lot. And perhaps this side of it's not been moving quite as much, not keeping up quite as much. So here, finally, we've put enough pressure at this area at the right point, right? Almost like a chiropractic adjustment here. Just pushed in exactly the right point to be able to release this part of the south flank now. And this is meaningful because this is the point that's right near this bend. And we know that once magma can make this bend and this rift zone segment opens, that's when we open a possibility of eruptions in this Middle East rift zone segment, which is more or less through there, right? Not the Lower East Rift. That's a whole other stage that would have to follow after a whole bunch more work the volcano would have to do. So, but to be real, that's where we are, is the Middle East Rift phase coming up next year. Who knows exactly when. So we'll look at that in GPS here shortly too, but let me get this zoom back out. There's a cross section, and now we have our month-long data. So tilt over the last month, and our scale is still quite large here. We're looking at 90 microradians top to bottom across this whole graph. Here is a segment of data before the calibration, where you do see more of whether these are deflation inflation signals. And I know that we talked about this a little bit previously, but because they've now said they've had to go physically into that vault and recalibrate this thing, I do wonder if they maybe opened the vault earlier, or if there's some kind of influence of the signal that we saw coming in more or less in here for this segment in here. So overall, a lot of this data has some questions about it, but you can see the overall trend is unquestionably a lot of inflation coming from southeast of Uekahuna for the whole of the last month. If we look at the Sand Hill Station, which we know does not have those issues of calibration, it has been calibrated, but the bad data has been removed. Can't quite see it. It might be in this gap right in here, where there's a little bit of a missing pixel right there. They cleared all that out so you can see what's going on. The Sand Hill Station has two components. The blue one usually points towards, or does point towards Halemaumau, and usually picks up the signal from inflation of that reservoir. But now it's kind of picking up a whole spread of things that maybe is not only Halemaumau. It is showing a little bit more deflation over the prior week, previous to today's reinflation with a South Caldera earthquakes coming in. However, the South Caldera signal, shown by the green component here, you can see has been steadily rising that entire time. Fairly steady rate all through here, slightly faster, slightly slower, quite a bit faster, a little bit slower. So on average, still climbing up, and maybe you're seeing some of this pulsing effect as we're seeing migration of pressure from maybe this Upper East Rift to the South Caldera to wherever else it might go, Halemaumau or beyond. And this is a similar pattern as we've seen going back to October of last year when earthquakes in the Southwest Rift really began, and really back to 2021 when we start seeing South Caldera earthquakes as well. So here's our depth time plot for the whole last month. And on here, most of these shallow events seem to all run together. There's our most recent South Flank event. And what we can maybe point out is that the deep earthquakes in Pahala are still ongoing here, and with no real meaningful pattern that I could pull out of it just visually at a glance here. So still ongoing. It seems like fairly normal, maybe a random steady rate there. And all the action has been in the shallower parts of the volcano here, which is why we like these maps that are colored by depth as a good way to see what's going on there. All right, so here's our last month, earthquakes per day. There was that Upper East Rift earthquake swarm. Here was that 4.1 and its aftershock sequence. And here is our most recent buildup of earthquakes beginning on the South Caldera area. Zooming out to look at earthquakes per week over the last year. And here's our week that we are in right now. You see we're coming in a little bit low. So this week is actually fairly quiet compared to the last two. Right, so the 2 weeks before that were quiet. Here's the one that preceded the eruption right there. So you can see overall a lot of variation, but a little bit lower this week than the previous two. But zooming out even more to look at earthquakes per month, this is interesting to me here. This dashed line is labeled February right there. Right? So that's more or less your reference. So this is July coming in here at the very right end. So let's just ignore that for now. It's not enough data. What you can see is June, May, April were all extremely earthquakey, when we had close to 3,500 to 4,000 earthquakes within each of those months. March was low, as you can see here. That was that recovery period from the January to February intrusion into the Southwest Rift, which accounted for these 2 high months of earthquakes here, about 3,000 earthquakes in those 2 months. And in December, that previous year. There was November was slightly lower, and yeah, October pretty high there, right? September eruption coming in here and build up to it as well. And what I wanted to point out overall is if you just look at this and something like 3-month chunks, this most recent 3-month chunk has been, what is that? Like probably over 10,000 earthquakes in the last 3 months here, which beats the previous 3 months, which beats the previous 3 months, and so on and so forth. The overall pattern has clearly been one of earthquakes building up more and more and more. So this is breaking a pattern we saw previously, where we saw here was the buildup to the December 2020 eruption and the first eruption in the summit following a 2018 collapse. And then it built up to the September 2021 eruption and its drop off for that eruption. And then again in 2022, we're now routinely exceeding the threshold of earthquakes it took to cause those eruptions, right? Which just goes to show that the volcano is in a state where it really can fill with magma, and it's doing more movement and adjustment underground through stretching and moving these blocks and earthquakes. And occasionally it's moving enough that lava actually manages to leak out a little bit, as we saw on June 3rd. But for the most part, it's doing most of this work underground, stretching and moving and expanding. Really, it's sprawling out as it fills. It's accommodating a huge amount of magma, but we're seeing very, very little of it at the surface now. We're seeing instead the earthquakes and GPS movements that are off the scale, and the tilt meter is doing interesting things and those kind of things. So that's the earthquakes there. And looking at GPS for the last year at the summit, we are missing the most recent data here. In the last couple of days seem to not be on the graph, but that's okay. What we can see from the recent pattern is that the volcano expands north and south across its caldera, sometimes more and sometimes less. When it's less, it's usually expanding in the quiet to the south. When it's more, it's usually a high magma. And that's a pattern we've seen for a while, where it it's just going through this, filling at the summit. This was the June eruption there, filling at the summit, and then relieving to the Kauai and filling. And then here we are since that eruption. It's been filling, and then finally here's our first little wiggle into the Kauai following the June eruption a month ago. So at present, we're still going through this kind of wiggling without knowing exactly which way the wiggle is headed in the most recent day here. That's at the summit. If we look down in the Middle East Rift Zone at Pu'o'o, that distance is still contracting. That line is getting shorter north to south, showing that that part of the rift zone is still contracting. And magma is not reaching that area to swell the ground upwards there yet. Right, this is the area that we're tracking, where that might happen next. Maybe not exactly at this location, but towards here. But there is no indication of that. No change in the overall pattern that's been here for over a year. So those are the monitoring signals there. I think we can get into GPS a little bit more, but we'll do that using this USGS map today. So all I've done here is come to our instruments, turn on our GPS, and plotted them on our map here as well. Right. So, for example, Uekahuna is up here in the top left. We click through. Let's go to the 2-year components. And I like to scroll down and look at the up-down component as one of my first passes here. And you can see that Uekahuna, after having slightly slowed down last week in response to that seismic swarm in Kauai, now seems to have resumed upwards once again to where you can't even tell there was a little wiggle anymore. It's just resumed that old pattern, the old trend there immediately. So that little relief that occurred following that seismic swarm seems to have been very short-lived, because that area is rising again. We look at Byron's Ledge. Here it is, still rising again as well. We come down to the Southwest Rift. This is Cone Peak. And it is rising again as well. Come down, let's come further all the way over to KOSM. This is the closest site to that eruption site from June. And it has not stopped rising, in fact, since eruption ended. So it's still recovering, likely in pathways open. Magma is going in there, and it's just filling like a balloon, swelling upwards there. So filling there, filling there, filling there. We can go further over. Let's go over here to, let's go to Devil's Throat. This is the one we saw showing that Kauai uplift last week there. So it seems to have stabilized a little bit now. It's a little bit of the opposite pattern, right? It's like an accordion. When one side moves this way, the other one's the middle is just shifting where the folds are, right? Where they're the densest. So you can see here in the Devil's Throat area, it moved upwards quite a bit during that Kauai swarm, but since has slowed. And then further over, we can look at stations like, well, I'll point out, this is Mana'ulu. Mana'ulu happens to have a lot of noise in it, so we don't really see a whole lot of data in here. This sometimes happens when you look at the data in this manner, but let's keep going over. For example, Kananui Ohamo over here is still dropping down. It was getting pushed more so from the west, so it's moving to the east, but that seems to have slowed slightly. So there's a lot of wiggle and variations happening right in here. The station that I really wanted to point out, and I feel is most important, that we've been tracking for a long time here, is this one, the Kalapana Trail Station. Our earthquake is just in line, right there. So this one is maybe one of the most interesting ones. So let's look at that. And if we look at what's happened most recently, you see it's got a extra push to the east. It's got a really strong push to the south right here. And this is the most important thing. Looking at the up-down, there's no big rise upwards yet. So this is likely still just a movement of the block from the pressure laterally rather than magma pushing it to the side and to the south. But you can see here that the signal is moving south faster than any point within the previous 2 years of this particular plot, right? And this is hard to explain just from here. So I got to go back to this 10-year plot now. I'm going to show you guys why this is actually important. So 10 years now, this is going back to 2014. So this right here is a 2018 eruption. Right? So here's our up-down, here's our north-south. We'll focus on those two primarily here. Right? So when that eruption occurs, the ground dropped down fairly quickly. When eruption was over, it recovered for a time up until about mid-2021, at which point it then began dropping downwards. And it's still dropping downwards. Even today, we saw that the ground is still dropping down, right? The north-south component showed that as magma came through the system in early May, it got pushed to the north. And then, let's see here. I'm sorry. So the eruption begins, and yeah, the station is being pushed to the north. The earthquake occurs. It gets offset to the south. The eruption continues, it ends, and now it continues moving south again. But the reason this is so important is that here in 2020-21, that southward movement that was faster than prior to the eruption, this is where it changes, and it starts moving to the north again. And if Kalapana Trail was moving to the north, let's bring up the map again, right here. If this is moving to the north, that's closing off this east rift zone. And that was exactly the same time we saw the beginning of earthquakes in the south caldera and to the southwest rift. So that was a shift that occurred back in 2021. Magma has been coming in for years, filled it up enough to where it caused like a little pinch zone right in here. This closed off, backfilled, filled the whole summit, filled the southwest rift, popped open the southwest rift that's full to bursting, clearly. And now it's refilling back to the east rift and Kauai zone, this whole triangle as well. So that's why I keep talking about why this particular, how steep this looks right here, how fast this is moving to the south. That is a point of concern there as far as magma coming back into this Middle East rift zone right through here. Right, and to just back that up with a, let's see here, where do I have that? Maybe I don't have that up here. We have a map from 2021. Where do I have that? Let's see, I'm gonna find that for you guys and throw it up here real quick. It is. I knew I was gonna forget something today, and this is apparently is it. But here we go. Throw it on here. There it is. This is from Jeffersonite Twitter at the time, showing these two clusters of earthquakes between August 24th and 28th, 2020-21. This is when a whole South Caldera pathway seems to have undergone a significant shift to where from this point onwards, we started seeing Southwest Rift Connector and Southwest Rift becoming more active as well as the Kauai and the East Rift Zone, Middle East Rift Zone go into that northward movement, dropping down and no more flow into the rift zone beyond that Upper East Rift Connector in 2021. So, okay, that's all those earthquakes. I think we can finish up the monitoring with our radar images, INSAR images here. And this is the most recent one released, showing inflation in this area just southwest of Kīlauea, the main caldera. The previous iteration of this, in case you're curious, so this is about a month of time here. The previous iteration of this was only about a week, but showed a similar pattern there as well. That same area right through there. So that's just the 1 week. And here's the whole month. And what you're really seeing is many more of these rings showing a greater accumulation of range change, right, of uplift towards a satellite in this area over that time. Right, and that's compared to what we saw during the eruption itself, where everything was flushed out and was opening all down through here. See how far it went compared to the trace of the new flows that occurred last month. And then going back to before that, just to continue this story, going back in time prior to that eruption, there was also inflation in that same area, right, with pretty good intensity. And prior to that, in that same area as well. So it's kind of more of the same, really, as far as those images show us. We also have the Mounts project, which is automating INSAR images as well, and slightly different parameters here. So we can look at the most recent image of that one. Here it is. This goes from June 20th to July 2nd. So it's a little subset of that period, and it's looking from a slightly different direction as well. So in this case, it's showing inflation here in a Kauai, right? And that makes sense if we saw all that pattern of Kauai buildup that we just showed you guys through all those plots just now. Right? So that's the most recent one. And then the week before that, it looked like this. And I mean, I would say 2 weeks before that, and the 2 weeks before that was eruption, and it looked like this. So here's where magma is leaving the summit and southwest rift and flushing down to the southwest. Right. So what I'm going to do now is, so this is an image from eruption on June 3rd, but we can go all the way back here to this image from February, which actually captures that intrusion that occurred at the end of January and February. So there is a very similar picture, magma leaving the summit region and that southwest rift connector / South Caldera area and flush to the southwest in that intrusion. So I'll move forward through time from February now, right? This is February 9th to the let's see, January 28th, February 9th. And then going forward, our focus shifts back to the Caldera. Going forward, it's now back to the Kauai and perhaps a little bit in the southwest connector as well. Going forward another 2 weeks, southwest rift connector for sure there. Next 2 weeks, oh, it's still down there. So maybe likes that area a little more. Then we had a big pulse into the Kauai. This was from April 21st to May 3rd. We had that pulse into the Kauai. Then it goes back to the Caldera, back to the Kauai. Then we have our eruption in the southwest rift. Goes back to the summit, southwest rift connector, back to the Kauai. And I put this here in this way so you can guess what happens next. It could be any of those things. It could be just inflating still in the Kauai, at the summit, southwest rift connector. And we're kind of stuck in this pattern until we wiggle enough of this south flank in the Kauai and the upper rift connectors that would lead to some longer term change, which is why I'm talking about the Middle East rift zone at this point in time. That's the long game, but that's where this seems to be headed to longer term. So that's the monitoring signals here for Kilauea. I will just very quickly mention Mauna Loa as well. So let's get Mauna Loa on the screen here. And I mentioned before that there was a little bit of an acceleration in the tilt here over the last week. On this plot, maybe it doesn't look quite so convincing, but it's important as always to look at the scale. Unlike some weeks, this week we have a scale of 9 microradians up top to bottom on this graph for the last week of tilt on Mauna Loa. Sometimes this has only been 1 microradian or 2 microradians, so this is a bigger range than normal. And in that context, you have to look at this range coming up here as a maybe 2 microradian increase that we're seeing over the last couple of days here. No earthquakes to go along with it, really, to speak of. Here is a month-long plot where it's a little bit more obvious to catch that increase, right? And we do have variations. We know that our seasonal coming on here as well, but this looks like it's a little too steep and to fall into that pattern. So nothing unusual happening there. I mean, maybe one extra deep earthquake going on, but no increase in shallow earthquakes. It's just part of the overall pattern. You maybe just have a slightly more shallow adjustment of the inflation there, and it's being picked up in the tilt meter. So earthquakes per day are still below 4 for all of last month, with many days with no events at all. So really all is fairly quiet Mauna Loa and nothing unexpected there. And that will be the volcano summary here for this week. So with that, I'm ready to pass it to Dane, who's been answering questions here in the chat and leading discussion. And let's do some questions before we take our mid-roll here.
Yeah, sounds good. We got a few of them here, especially with the talk of the Middle East Rift Zone. We have a couple on that. We'll start with the first one's from Facebook, so I can't put it on screen. Diane asks, is an eruption imminent where the earthquakes are happening? I believe that's a common question. We're going to have a few common questions.
Yeah, so I mean, no, it's not imminent. That's what the USGS is saying. The eruption is not imminent there. that's really, I can see where the challenge is there, because we've seen earthquake counts and patterns like this, where we've said this is a pattern that looks like something's imminent, right? But the context we have here is that this has been going on in this same context since October, and the volcano has shown that its threshold to erupt is a little different, right? In this area especially, right? We saw that Southwest Rift eruption a month ago had lots of earthquakes in this area, and then none to the southwest before it erupted over there. So that area to the southwest is maybe a little less sensitive to earthquakes, right? But even when magma was erupting at Pu'o'o, over here in the Middle East Rift Zone before 2018, you'd commonly have earthquakes in this area as well. This is an area that's shown earthquakes quite a lot over the years whenever the volcano is pressurized. And it does that because it's both the pathway for magma, this upper east rift connector, as well as being the boundary of this structural zone, this kind of zone of faults that's all stacked like a bunch of sheets in this direction like this, right? So it's got a dual role there. And I think all rift zones by definition have a little bit of a dual role, but this one's a little unique in how it's evolved in this age and geometry. Not to get too far into the weeds there, but a rift zone is a combination of a fault pathway that's accommodating movement that's also being used by the magma to go somewhere, right? So it's like a fault being used as a magma path. And so sometimes the magma is pushing more, sometimes gravity is pulling more and actually opening a crack in a fault zone more. And either way, that's the interaction you have there. So this area is as we've shown in that 5-year graph, has been showing more and more earthquakes every week, every month. And this overall showing a pressure of the whole area, I would say. Like I would draw a pressurized area like this whole zone. And in that context, anywhere in there an eruption is possible, right? I wouldn't say imminent, but possible, where, it could be within a short buildup, you might have an eruption occurring within that zone. For it to go somewhere out of the zone, let's say over here, then we need to see more earthquakes occurring over here first, because this area does not earthquake like this one whenever the volcano is pressurized. This area over here now earthquakes when magma is moving into it and through it. So it's a little bit of knowing the parts of the volcano, the different regions, their history, their context, how they behave. And that's a discussion I can add. I am sure that other seismologists who have been studying this volcano much longer than I have will have much more insight and depth to add there, as far as like, this behaves this way only sometimes when this is the case. And without taking it to that level of depth, that's where I'll leave it. That this area does seem to be able to withstand a lot of earthquakes without interruption. And in fact, if I go back to, I don't know if I have it on the screen here, but if you go back to the information statement that the USGS released following the earthquake swarm in this area, they note that while there's lots of pit craters showing magma movement in this area, eruptions in this area typically occur either at the north end of it by the Caldera or at the south end of it by the bend in the rift zone. That's the most common locations for things to happen, all through there. Whereas eruptions in the middle part of this are actually pretty rare. So that's just from the geology of going out there and looking for flows and trying to get relative ages of lava flows and how frequently do these things happen, right? And it's just less frequent here than most other places. It doesn't get out as easy. It's more of a connector pathway than it is an eruption site right in between here. And maybe that's why it quakes more. And now I'm past my knowledge bank here, so I'll leave it at that.
I think you answered the question though. Is it imminent? No, not there.
No, but yeah, that's kind of yeah. I wanted to go beyond that, right? USGS is saying it's not imminent, but clearly that's not enough information. So that's why I like to discuss as much as I can. Even if I don't know exactly the answer, we'll discuss what the issues actually are.
All right. Dennis asks, if the Middle East Rift Zone opens back up, can Pu'o'o reactivate?
It's possible that could happen. I feel like it's been so many years that it's highly unlikely that pathway is viable anymore. I think that you could have an eruption nearby there, and then if you call it Pu'o'o or something else, it will be a whole other issue. I feel like it's been long enough you'd call it something new. So my answer is going to be no. It can't reactivate, although somewhere nearby there could activate and might be called something else.
All right.
That's my personal take.
LM Hill asks, what is the volume of lava now in the caldera and is comparable to the volume held at the crest of 2018? So basically the refilling since 2018. How are we doing on that front? Most of it regenerated or has refilled. Most of it hasn't.
Yeah, I haven't redone the numbers in a while, but I want to say that the last time I checked, we might have been somewhere between 1/4 and 1/3 of the volume recovered, right? So that's your answer. Is maybe in a range of 30-ish%, 25 to 30%. I'd have to go back and look more closely there, right?
Good question.
Yeah. But the volume of lava in the caldera hasn't changed since last year in September, really, right? We're seeing addition of volume underground, and so the other factor here, which is not exactly easy to answer, is it takes the USGS geologists or others, geophysicists making these models, is accounting for the whole inflation of the whole Kauai area and injection in the Southwest Rift and injection in the Southeast Rift, that whole volume altogether. How much is that compared to before, right? So now then you can actually get to what is the rate of magma coming to the volcano? How does that compare to before? And maybe that's the more important thing, is how much is coming in, so what could it do from there, right? If it's all on a summit, could it refill the summit? That's been our question for years. How fast could a summit refill? Now it's not bound to the summit. Where else could it go? How big a flow could it make? How long could it last? Those are the natural questions that follow. Right? So to get to all of those things, you really want to get to the magma supply. And yeah, so the crater is filled in a lot. That turns out in hindsight now to have been an earlier phase. We're now into a new phase where we're involving outside the caldera magma coming into mostly underground with one tiny little bit of lava leaked out to Southwest Rift last month.
Right. Yvonne asks about the new INSAR. The uplift was greatest at the South Caldera, but the seismic swarm was in the East Rift connector. My understanding would suggest that the connector is still open and responding to the uplift and the magma storage there. Any other plausible ideas, or is that correct?
Yeah, I mean, I think the connector, I think that right now, I mean, my take would be that both connectors are probably open. You're seeing that this much activity on the Upper East Rift, and so yeah, I didn't mention exactly, right, but you have a 4.1 that occurs on a 6th, and you have a lot of earthquakes that follow that afterwards, right? All the way here's a 3.4 and a 30th, right? So there's a little bit of a delay there. Oh, I'm sorry, I got this backwards now. 6. So let's see let's find maybe I don't have this quite filtered the right way. Let's go back to the last 2 days now to find one of these, right? So you still have earthquakes here, 2.7 happening after the fact. So there could be that because you move the flank a little bit and you allow more pathway of magma in here, you somehow accommodate more earthquakes, whether it's magma coming in or it's this whole area adjusting and slipping that way as well. Magma could be coming in here, or could be coming in here, or could be coming in here. I mean, any number of these different geometries that are possible. And yeah, I think that you basically have it right, Yvonne. I mean, I don't know that I can really add anything that's more insightful than that. But it does seem that the East Rift is it activates both when magma is moving through it and when magma is activating a Kauai next to it as well. So I don't know that I exclude either one at this point. That's maybe how I'll leave it.
All right. So moving on to the next one, we have a question from Dennis. It's this one that maybe help everybody out. We've talked about it before, but on the tilt graphs, the numbers on the top upper right, are those the azimuths that the measurement is taking along?
On the upper left, yes, it is.
No.
Let's see if I can get one of those up here. Yeah. So, for example, this one, yes. 226 is the azimuth of the blue component, and 316 you have the green component. With the caveat that you're right, like they can then make the line go up or down, and they typically make it go up if the area at the summit's inflating, right? And so sometimes you end up looking at an azimuth that's 180 off of this, right? So instead of actually being 226, I think of it as 46 degrees. This is going northeast towards Halemaumau, right? Or opposite ways. It's from Halemaumau 226 to here. Hopefully that's enough. I won't do any more math to confuse anybody, right? But that's basically it there.
Next one I can get from Facebook, Quiglin asks, just want to know if there's a new road to Poiki Beach Park and want to know if it's open. What road do you take? There is a new road. It was the road that was established just after the 2018 eruption that runs along Highway 137. And that is currently the only access into Poiki, but there is slated road construction set to start in the next couple months to restore Poiki Road. And we will be talking about that in the coming weeks more. Final question for you. We've had this talked about a couple times already, so I figured I'd just throw it in there. From Vancouver Island, we had a 6.4 magnitude earthquake this morning. Do you think the quakes on the west coast of North America and the 7.1 earthquake in the Philippine area and Hawaii are connected?
I do not think so myself. There's just too much distance and too many other variables in between these areas there, right? There are connections, obviously, as far as a whole Earth system and how the Earth works and into the Earth and all that. But to say that within the time scale of these events happening, that one is affecting another, to me is too far of a stretch. Where I don't see any physical mechanism that can actually account for that, right? What can happen sometimes is, let's say your volcano is super inflated and pressurized and about ready to go, and then there's a faraway earthquake. Now suddenly the whole volcano starts rocking together as a whole. Like it's not like usual. Normally the volcano is like pressurized in the middle, so this side's going this way, this side's going that way, right? When it's swelling up. But during a fire earthquake, they're both swaying together. So it's kind of just like giving it a nice big gentle rock all across the board there. So you can cause some kind of event, whether it's like a degassing event or a small eruption or like something like that from a far event, if your volcano is about to go anyways, right? And in that case, it could be a far earthquake. It might be the tides. It could be something solar in that case, right? But the volcano's got to be ready to go already at that point in time. That's basically it.
So we'll do one more question, how about? And then we'll call it good for this segment. Last question comes through. Oh, whoops. Luke, can you, whoops. There, that actually worked. All right. So Kristen asks on Facebook, when it's mentioned in the text above that the residents are facing an increased seismic threat, can you clarify if you mean the island as a whole is facing the potential of a large earthquake, like a magnitude 5 or 6.9 that accompanied the polyslip just prior to 2018 on the Lower East Rift Zone? Or is this more localized to the volcano and or summit area with many shallow, lower magnitude earthquakes possible, or both?
Yeah, that's a great question. Honestly, it began as we're looking at that graph. We're seeing earthquakes are increasing every single week, every single month. Earthquakes are more common, especially in the volcano area. We saw 4.1 go off in the south flank as a result. So overall, it's just we should always be prepared for earthquakes, really. And what we're seeing is just a little prompt to remind us that we should always be prepared for earthquakes, because at the summit of Kilauea, they are more likely for sure now. Maybe not anything huge, right? But we are just overall seeing more earthquakes. Pahala's got more earthquakes for many, many years now. And if we are going to start moving the south flank, like a 4.1 is not that big, but I'm not saying anything is imminent either, earthquake-wise. But over the next several years, it's easy to imagine that the south flank keeps moving, and there will be more events of larger magnitudes in the south flank. And it just seemed like today was a good day to put an extra reminder for everyone to think about earthquakes, preparing yourself now. Now that nothing is about to go or seemingly urgent or imminent, but it's a gentle reminder. Look, there's a lot of earthquakes happening. It's a lot more than usual. It's actually the last 3 months have had more earthquakes than any time in the last 5 years. So heads up, there might be more earthquakes.
Right.
Let's be ready.
I was going to end it there, but I did have one question I wanted to ask. Is that Middle East rift zone reactivation, does it necessitate a larger earthquake, say 5, 6, 7 plus, or can it happen through many smaller earthquakes, the same intrusion, essentially?
I mean, it could happen through many smaller ones, but it would take a lot of them, right? When you start thinking about the logarithmic scale of events, you're almost always going to get something larger, right? And I think, I'm thinking on a scale of a six-ish, we'll call it, right? 6 to 7, somewhere in that range. But it could be that as we approach that, we see more smaller events occurring more frequently over time, just by just showing that south flank is being pushed through intrusion. We would see if there is intrusion, the GPS signals on the rift zone showing uplift, showing spreading of the rift zone and all of that. And when we have all that happening together, then we'll really be in much more of okay, there could be a big one at some point in time. But the big ones are always so hard to predict. They can happen so sporadically. I would never try to call one of those in advance. I just, it's just like, like if the south flank is moving now, so much pressurized that much, then, there could be one anytime in the next, we'll call it 5 years. Right. Not like 5 days, but, in the next 5 years, there could be more big earthquakes. And so since that's what we talk about every single week, it seems like, as earthquakes, we should also make sure we're prepared for them.
All right. I think my answer to that question would just be yes. Yes, both. Just be aware. We always have the potential for some kind of large earthquake, even if it doesn't relate directly to the volcanoes, one of those flexure earthquakes we've seen. So there's always that.
Yeah, that's what I want to explain. That's coming from the data, right? From the data, like the monthly counts, like the weekly counts, right? And it's not something the USGS has said. It's just something that I'm picking up from the data, and I'm just using that as a prompt for us to all be reminded to be prepared. Since really that's our mission here at HVERI, right, is to improve our preparedness and response and recovery through education. So even spending minutes talking about preparation for earthquakes, that's our goal.
All right, I think that gets us through the Q&A. I appreciate everybody. If you didn't get your question answered, go ahead and drop it in the chat again, and I'll try and answer it there. I think now we will transition to talk a little bit about fundraising, huh? Bring on Lou. So, Phil, I think you'll be rejoining us momentarily, and we'll bring on Lou now. All right. Hey, Lou, how you doing?
I'm good. Oh, good to have Phil back, huh?
Yeah, right.
Woo, that was quite an earful. I don't know. This is a rewatch tonight to put what you and I experienced the last couple of weeks together into just an hour. Whew, nice work, Phil. And by the way, is heads up, is that a scientific term, Phil? Just curious. So I'm gonna go ahead and kick this on here. Yes, it is the summer donation drive. And first and foremost, I'd like to thank Kilauea Recovery Grant and Puna Strong County of Hawaii for the grants that we get through them. Keep us going, and all of you who have donated to us over the past several months and years to fund our programs. This summer, we're also focusing on businesses. If you have a corporation or a business and you would like to sponsor one of our programs, maybe an event that we do, go ahead. I'm going to drop this link in the chat here. It is hveri.org/contact. Send us an email. We can discuss that, and you'd really help us out. And we have some stuff planned. Dane already kind of snuck it in a little bit with the Pohiki Road. Dane and I are going to do a live stream, I think, weather permitting. That's our only hiccup here. You guys know that. But Dane's a little drier down there in Leilani in that area than I am up here. So, well, a little bit. I mean, I know it's a stone's throw. We can only hope.
All right. Yeah. So we are launching our donation drive for our summer fundraiser. Starts today. It's going to run for a month. So Any and all support, we appreciate it. We did have a $20 donation from Lisa Lynch, super chat. No comment, so just wanted to recognize that. Thank you, Lisa.
Thank you very much. You can donate here as super chat or super sticker. You can also reach us. The best way is on our website at hveri.org/donate. There's the link on the screen right there. Thank you very much, everybody. And I know we have a pretty cool video set up for tonight. And that's all I have. Stay tuned. Make sure the notification bell is hit so that you don't miss when we go live for something that's coming up for the donation drive and for anything else that might happen here at HVERI. Thanks, everybody.
Sorry about that. All right. And thank you, Lou, for jumping in. And we will see you later. I'm sure updates throughout the month as we continue on our donation drive.
Absolutely. Oh, one more thing. If your name was on that reel of all the thank yous, that's going to get reset here. So I'll have a new chance for maybe a little more opportunity to get through the list this time. So that is going to be reset for everybody that donates throughout the summer donation drive. So thanks you very much. Catch you later.
All right. Thank you, Lou. And I think we will get into our final segment here, which is going to be the rehash of the 2018 eruption, looking at June 30th through July 14th, the 2 weeks there that the lava channel ended up changing dramatically to end up wrapping around Green Mountain and the Kapoho crater. So we'll talk about that a little bit more. We have a video lined up for you. Welcome back, Phil.
Thanks. Take it away, Dan.
All right. So yeah, I think we can go ahead and get into it. We'll let it play and yeah, maybe pause it whenever you got something to say. June 30th, back down in Kapoho. The ocean entry has had some deviations over the previous days, and it's starting to work its way back to the north, which means more bad news for the very few remaining homes in Kapoho. This ocean entry has been developing over the previous week or two, such that it is not varying as much, but it's starting to look like it's developing some tube systems very close to the coastline, where it will enter into an area that has a solidified top, but the inside is still molten, kind of like a jelly donut, so to speak, and the lava is able to flow through that molten layer to make it to the coast. But what we're seeing now is it's starting to somewhat seem like it's creating a backup, and that's causing some additional variations. The lava channel at this point, though, has been pretty consistent. There hasn't been any breaches or any diversions that have significantly changed the course of the lava. It's still confined to the channel walls, with the occasional overflow just making those channel walls a little bit more robust each time. Though the lava channel hasn't really changed much over the previous couple of weeks, it's still very interesting. One of the phenomena that we've observed is these lavanados, these vortexes of hot air that are able to throw little bits of molten rock out of the lava channel.
All right, this is June 30th. This is Stacy Welch. This is Fissure 8.
So while the main thing going on still is the eruption at Fissure 8 and that 7-mile long lava channel going down to feed this 2-mile wide ocean entry, there's more activity taking place, primarily at Fissure 22. Now, while Fissure 8 is in this effusive style eruption with this large flow, Fissure 22 is in a strombolian style activity, which means it's not producing a lava flow, but it's throwing a lot of rocks up into the air, which are landing and forming a very pronounced cone. This is the type of cone that if you asked a small child to draw a volcano, they would probably draw up for you. It is now July 1st. We're on the morning overflight with Bruce Omori and Mick Calver as they fly over Kapoho. We see that the lava delta that was encroaching into the subdivision has not advanced significantly overnight, which is a little bit of good news. You kind of take whatever good news you can get in this situation. But I want to focus a little bit on this section of the lava channel right by Green Mountain. This is going to become more important as the episode progresses, and over the next couple of days we're going to see some changes here. But as of right now, it still remains very similar to what it has been over the previous couple of weeks. As evening progresses on July 1st, we start to see that this lava channel is no longer feeding into this tube-like system in the lava delta, which then percolates the lava out into the ocean, but is reset and is flowing on top of the lava delta. Now, that's a change that we haven't really seen up until this point, and starts to make some impacts. The first immediate impact is lava is continuing its advancement back into Kapoho, so more homes are lost. Meanwhile, back up at Fissure 8, not much has changed significantly. The only real variation is in the forms of the pulses and surges that we've discussed previously and are ongoing. The lava channel and the vent itself is mostly stable and erupting in a steady state. There is some variation though when it rains, and not in the eruption itself, but more in the weather. This eruption is creating its own weather patterns, its own little microclimate, which includes a tremendous amount of rainfall for Leilani Estates. There are days where it rains 12 inches in less than 12 hours. It's simply incredible amounts of rain being thrown down on Leilani Estates. It's directly downwind from this erupting fissure. We end July 2nd with a look at the thermal map produced by the USGS, and this thermal map shows that the ocean entry has changed with that lava flow that's now flowing on top of the lava delta, as well as the expansion of the flanks into the Kapoho farm lots, which is claiming more homes as the day progresses. We also get a look at Fissure 22 up by the Puna Geothermal Venture doing its strombolian activity. July 3rd is when things start to change down by Green Mountain. The lava channel that was running down Highway 132 before it made a dogleg bend around the crater to go towards Kapoho has backed up, is overflowing, and is starting to look like it's going to divert itself. Now we haven't seen this before in this eruption. It's been very stable lava channel up until this point. Unfortunately, as the lava channel starts to get more volatile, it begins to re-advance into the Kapoho beach lots and farm lots, destroying some of the few remaining homes in that area. The blue home, that 3-story newly built home that was down in the beach lots, that was kind of that symbol of resilience, that flow stopped right on its doorstep, is now gone as well. We rejoin on July 4th with Mick Calver and Bruce Amari in the morning overflight. We're looking down at that section of the bend around the Kapoho crater, Green Mountain, that funnels lava down to Kapoho. Now, this bend was one lava channel. It overflowed the previous day, and now it looks like there's an inner lava channel that is running through a small section of tube before rejoining with the original lava channel around the bend. It is now July 5th. We rejoin Akaika Marzo back on his boat offshore of Kapoho. Now, one thing that Akaika documents right here that isn't very much talked about is the massive casualties that the marine life underwent from the ocean entry and the algae bloom that came about a little bit later. And you can see here all these dead fish, and there's also dead turtles on the coastline. It's heartbreaking stuff. It's not just, new land being created. There is hardships that not just the people underwent. Also on July 5th, we get another look at the bend the lava channel makes around Green Mountain down by Four Corners as it makes its way to Kapoho. This area has been volatile the previous couple days, but it's starting to look like the lava channel is developing more and there's less overflows here. Maybe that was just a little hiccup. At this point in time, we really don't know. We step into July 6th with another look at the bend of the lava channel around the Kapoho crater. It's seemingly becoming more and more developed. That small section of tube looks like it's being whittled away in terms of the amount of volume going through there as the alternative lava channel around it gets more pronounced. Maybe it's over in terms of the changes of the lava channel. Maybe it's not. We end July 6th by looking at another thermal map produced by the USGS, which shows some of the changes that have been taking place in the Kapoho area, including that more pronounced dogleg that has come about near the Four Corners in the Kapoho crater. Fissure 22 is still having that strombolian activity as Fissure 8 continues its dominance. We pick up on July 7th back down in Kapoho. The area around Four Corners has seen this lava channel changed over the previous couple of days as it redirected itself around the Kapoho crater and formed this more pronounced dogleg. The lava is still encroaching into the Kapoho farm lots, destroying more of those very few remaining homes that remain. The lava channel in this lower section has two features that have been becoming more and more clear. The first is that inner lava tube that feeds back into the lava channel has slowed to the point where it's almost crusting over. The second is this lava fall. Based on the topographical features that were formed in the previous part of the eruption, now the lava flows over it and drops down a couple feet before rejoining the channel and continuing down. At night, again, it's so much easier to see exactly where the lava's flowing, where it's oozing out of, and all the little details, as opposed to the day where it's just different types of gray on gray and different tints to the black. We're now in July 8th and we are flying with Mick Calver and Bruce Omari, and we're going to be looking at the Ku'ukola Charter School on the A'alenui Warm Pond. These are treasured areas for many people. There's many people in the community that have raised their kids through the Ku'ukola Charter School and the whole Red Road community. And we also have the A'alenui Warm Pond, which was built because a previous beach park was destroyed in the Pu'uo'o eruption. The A'alenui Warm Pond was established as an alternative site, and now it's getting threatened more and more each day. Here we can see a shot of the ocean entry in one of these predominantly active areas that the lava is funneling through the lava delta to make that ocean entry, and it's on that southern edge nearest to the A'alenui Warm Ponds, the Ku'ukola Charter School, and also one of my favorite spots, Secrets. Meanwhile, at Fissure 8, there really hasn't been any significant changes. The only real change is in the form of the surges, but we'll discuss that a little bit more later. Right now, the status quo remains. The Fissure 8 is continuing to be the one primary fissure where the eruption is focusing, with a little bit of intermittent strombolian activity at Fissure 22, but it is the show of Fissure 8. We end July 8th with a look at the USGS thermal map, which shows the lava channel still feeding down to the Kapoho region, but there things start to get a little bit different. Now this lava flow is primarily moving along the southern edge and working towards the A'alenui Warm Pond, while these northern flanks are still expanding as well. The lava flow, just because the channel stops feeding it, doesn't mean that the leading edge stops immediately, and that's one of the things that we will continue to see throughout this eruption. On the morning of July 9th, we rejoined Mick Calver and Bruce Omari on their morning overflight. Here we're flying over the areas south of the A'alenui Warm Ponds, the areas around Po'iki, which include the shacks and bowls surf spots, first bay, second bay, dead trees, elevators, all these areas that the people that are familiar with the area have grown over the decades to love and cherish. All right, so we need to focus on that lava channel for a little bit because there's some big changes coming its way. Up until this point, that lava channel that has established itself over the course of June and the first part of July hasn't really changed itself significantly over the course of the eruption. There's been some overflows and some small breaches, but these are rather short-lived and more or less contribute to the robustness of the lava channel. But today that changes. The lava channel ends up backing up down near Kapoho crater. That area that we've been discussing over the previous couple of days is now compromised entirely. The lava starts to divert itself and pool in multiple directions, including the north and south. The one to the north, though, is the primary concern because there are residents in that direction. And the authorities don't play around with this at all. As soon as the lava starts coming out of the channel and moving north, they issue evacuation orders. And that overflow is eventually going to stall, and the lava channel primarily starts moving to the south. As the day progresses, this overflow area has worked its way down to the backside of the Kapoho crater, where it's pooling and still trying to figure out exactly what direction it's going to end up taking. We end July 9th with another look at the thermal map produced by the USGS, which shows this overflow area on the backside of the Kapoho crater, Green Mountain, and the pooling of lava that's occurring there. But also upslope of that, further Malka, in the braided section of the channel, we see that there's overflows occurring there as well. And this is all due to that backup in the lower section of the lava channel.
We step into July 10th and we're on board with Bruce Amari and Mick Calver on the morning overflight over the area that had backed up and overflowed the previous day behind the Kapoho crater, also known as Green Mountain. We see the very beginning stages of this lava channel being established that wraps on the backside of the Kapoho crater, running down towards the Aholonui Warm Pond and the Kīlauea Charter School. We also see this one lone surviving house that has been completely surrounded by lava that has worked its way very close to the foundation. But it still remains intact. And that's, a juxtaposition from all this land that has been converted into just new rock, and to have this one standing home in the middle of it all. We jump back up to Fissure 8 to take a look at a very steamy flow field following a rainstorm that had passed over the lava flow. Still hot molten magma stored underneath the crusted surface, so water gets in, steam comes up. But in it, Mick Calver captures one of the best videos of a funnel cloud vortex of hot air coming off of the flow field, this tornado of steam that I saw in the eruption. Later that same day, still July 10th, the lava channel backs up again, this time just upslope of the previous backup on the backside of the Kapoho crater. That lava channel that was getting established earlier this morning is seemingly been evacuated, with the fresh lava no longer feeding through it. The flow is expanding on the flanks again and intruding into areas that had yet to been inundated and burning off some of that vegetation. The south side of the lava flow is significantly more dry and dead than the north side, as the predominant winds have been pushing the volcanic gases from the lava flow over that area, killing the vegetation. The lava flows themselves have their own natural sound to them. They're quite interesting to just hear the molten rock roll across the landscape. It was really difficult to capture this though. The first thing was the wind, the second was the helicopter noise, and the third was the eruptive volume of the fissures themselves. But here's a clip from USGS. We end July 10th by taking another look at the thermal map produced by the USGS. This one was taken at 6 a.m. in the morning on the 10th, so it doesn't capture that afternoon backup overflow situation that was taking place just behind Green Mountain. Otherwise, it looks very similar to the previous days, plus some overflows that have occurred even further up near the Y of Highway 132 and Po'oiki Road. Also, the overflows on the braided section have seemingly solidified and the lava is back inside the channel. On the morning of July 12th, we get the bad news that the Kilauea Charter School, the Aholonui Warm Pond, and the secret surf spot have been essentially removed from the map as lava inundated the area and buried them all. That breakout, that overflow area on the backside of Green Mountain that we were watching on July 9th and 10th, managed to get some structure to it and channelize on the backside of Green Mountain, running down the flank of the lava delta that has already been established, funneling it straight into these cherished areas. And that's, heartbreaking for many people. And the question that I keep hearing is, how much more are we going to lose? Bruce Amari and Mick Calver also managed to catch one of these littoral explosions that occur more offshore, away from the coastline than we've seen previously. And this will become more important later. We end July 12th with another look at the thermal map produced by the USGS. This one shows two different things. One is the lava flow that has diverted around the Green Mountain on the backside, Malka, of the previous lava delta, and flowed straight down into the Aholonui Warm Pond, as well as some overflows that have been occurring in Leilani Estates on the upper part of the lava channel right beside Fissure 8. And some of these have managed to get off of the previous lava flows and even destroy a couple homes in Leilani Estates. Throughout July 13th and even the 14th, the newly established lava channel that's running down on the backside of Green Mountain continues to establish itself and build up more and more each day. That lava is moving through there pretty cleanly right now and flowing into the Aholonui area and continuing to work further to the south and to the west.
Oh, all right. Yeah, so that was the 2 weeks there, roughly, of the lava channel migration change that we saw just Malka of the Kapoho crater, and a few other things in there as well. It's always hard to see secrets again. Like, that was my spot, but yeah, a lot of people have their own little spot that they love down there, and I'm sure that's hard to see it, getting threatened, and what the story leads to.
Yeah, this was a rough period 6 years ago. Yeah, for a lot of reasons. I mean, there had been a lot already happening. Everyone had already been through 2 months of this. To then have the loss come back, we kind of gone through a little lull of loss also, right? Because after Kapoho, which was a huge hit, huge numbers of houses in a very short time, there was kind of not a whole lot left to destroy after that, right? I kind of
Right.
was overflowing the edges and getting a couple here, a couple there, a couple here, a couple there, and then boom, the big diversion to the south, and all areas that had not been
Right.
overrun being gone all in a single night. That was a rough morning. What
Right.
followed next will come to this, I'm sure, in the weeks to come. But then that flow from there kept inching its way towards Pohoiki, and we still talk Pohoiki today, right? That's as far as the impact of all of that, and that was the beginning of it. Was that diversion that occurred July 9th and 10th there too? So
yeah, there's something to what you're saying about the Kapoho. When that fell, people were really numb, and
yeah,
that numbness kind of lingered for 3 weeks or so, 2 weeks or so.
yeah.
And
Until
then just
yeah.
when people thought their pain receptors were totally numbed, we realized, nope, they were still responsive. And that one night happened where we lost a bunch more.
Yeah, for sure. Yeah, there's a lot more we can get into there. I'm sure we could, pick out the scab for many years still here, right? But I think I'm happy to just leave it at that for today and dig into that some other time.
Yeah, I think so as well. Yeah, it's always rough going back and looking at, especially at this period in time, because there's parts that you remember clearly, but it's not this month, like, to me at least.
Right.
And
Right.
maybe that had to do with sleep deprivation, but the first month I remember much more than the second and third, where recreating this Drones On series would be a real challenge now, especially in those later months. So I'm
Right.
glad we have it.
Yeah, good job doing that right after the fact there. Yeah, so maybe we'll transition from here to just do community corner and wrap it up, huh? That sound all right?
Yeah, sounds good.
All right, so we'll put 2018 back to the side and just a reminder to all of us: this is why we do this. Was how we began, was by covering 2018. This is why we're connecting with all of you guys in the community. Just because of this, we're all through this together. And yeah, all of everything we're doing, all of our programs, all of the education, outreach, our resilience work with civil defense, with Vibrant Hawaii, all of that is why we do this, right? And why we come to you guys asking for donations once again is to keep this work going. And so, good reminder for us if we're not always on the ball or in the zone or what have you, right? This is why. This is our big why. So good to at least remind ourselves of that, right? So by switching gears to our community corner, let's talk about a few minor things here and then wrap it up. So in the national park, there are still area closures and delays ongoing. Lots of things we've talked about before. Here is a full list of closures still ongoing. And I will only highlight one here, which is new, which is right here. From 9th of July, 2024, Crater Rim Drive near KMC, one lane will be closed where it intersects the Western Mode Road as contractors install a new water line to the USGS facility. This is separate from that sinkhole which occurred there last week, but the same area, more or less. So that's the most recent addition to this list. And we still have pending this as early as September 2024, the Kilauea Visitor Center, restrooms, lanai, parking lot, closed. All of it closed for up to 2 years when construction and expansion begins. and they will likely relocate many of their services to other locations besides that visitor center. More on that as it approaches. So that's the construction updates. There are July events in the national park as well. Of the ones that are still in the future here, John Kīlauea coming up next week in concert. And then the big one is a cultural festival on Saturday, July 20th from 10 a.m. to 3 p.m. at the Kahuku unit as well. That's a big one, more than that. It's the second here, but then to finish off the month, there is an After Dark in a Park on July 23rd on Kenichi Maehara, Pele's photographer, which I think will be very interesting because those early 20th century photographers captured some really priceless imagery that we now treasure because there's very few images of the volcano at that time. So that's the events for July, and a little bit more. They've actually announced performers and activities for the Cultural Festival on July 20th. So that is there as well, right? There's all kinds of stuff planned there. Lots of performers, lauhala, Hawaiian games, fishhook making, etc., etc. So there's also Paniolo history, food, catering, and lots of stuff like that. So save the date for July 20th. And that is it for Community Corner. And unless we got anything else to discuss, Dane?
I think that's about it. Did want to give a shout out. We had a $2 super chat come through from Swizzle. So just wanted to recognize that. Appreciate the support there.
Mahalo for that. And yeah, and just one last thing here. I see a comment from Yvonne on this little closure. She says it's only the intersection where you go to the gas station at KMC and the road to the gas station that's actually closed.
Oh, so that's good to know.
Yeah, just a little section there. All right. So yeah, thank you guys for joining us today. Until next week, unless something else happens, our usual pattern. We'll be back on Thursday at our usual time. Anything else, Dane?
I think that's it. Thank you, and welcome back, Phil.
Thanks, and thank you guys for all your support in the past few weeks. Great to have our ASL team back with us this week as well. Mahalo, Carrie, and Dano. And until next week, from us here at the Hawaiian Volcano Education and Resilience Institute, I'm geologist Philip Ong, Mr. Dane DuPont. Aloha, everybody. Can I find the right outro here? Okay, here we go. Aloha.